So now let us see another important problem. Very interesting. A block of mass small m is projected from a wall A with velocity 2v on the rough surface with constant sliding friction to hit the wall B with velocity v as shown in figure. With what velocity same mass m should be projected to hit the wall B with same velocity v if the surface is now moving upward with an acceleration 4g. So first we'll try to understand the problem. This is wall A. On wall A block M is placed, and between wall A and this is wall B. Between wall A and wall B, a rough surface is there. This is rough surface. Okay, this is rough surface. On rough surface, this block M is moving, and initially it is projected with velocity 2v, and it reaches to velocity v. Okay, so options are there. Here you can pause the next. What is happening? Next case is this rough surface moves with acceleration 4g in upward direction. Then what should be the velocity has to be imparted to the block M so that it reaches with the same velocity to the block B. Okay, simple, very easy concept, very easy problem, interesting. Before that, what is the basic concept involved in this, we'll see. So v square minus u square equal to 2as, and here acceleration is deceleration. When you substitute, you have to take minus 2as. Okay, this is the basic formula you can use. Another concept here we use is the friction concept, and on the rough surface the block M is taken and its weight acts vertically downward and normal reaction is upward. Okay, so here friction is F equal to mu n, this is the frictional force, and mu mg, and what is the acceleration? A equal to mu g. Okay, so with this acceleration it is moving. And next is another in this problem related to this, another case is another important concept is this rough surface is moving with acceleration, some acceleration in upward direction. Say the rough surface, this is rough surface is moving with acceleration a in upward direction. Then the block experiences a pseudo force. Okay, so the mg acts vertically downwards, and because the block is moving up, this base rough surface moving up, the pseudo force acts downward, which is equal to ma. The normal reaction n as usual. So n equal to, you can write as ma plus mg. Okay, so we'll solve the problem. Initially the it is projected with velocity 2v and reaches to velocity v. Okay, so the acceleration is a equal to mu g. Let us write equation v square minus u square equal to 2as. This is the basic equation. With what velocity it is projected? 2v square, sorry, it is projected with 2v, but it is reaching with velocity v square to the wall minus 2v square. This is equal to minus 2 mu g. The displacement, the distance traveled is 2d d. So this is how much? Finally you will get 3v square is equal to 2 mu g into t. Now the second case is the normal reaction is, and what are the downward forces? Mg and a pseudo force ma. Okay, so frictional force now it becomes mu n, that is mu mg plus ma. A is 4g is given, it is therefore here I can write 4 mg. So from here what is the acceleration? 5 mu g. So that will substitute in this in the equation. V square, with what velocity it has to reach? They are asking it reaches with the same velocity. Then with what velocity you have to project? Say some u1 square is equal to minus, now a is 5 mu g, say 10 mu g d. Okay, so 2 mu g d we got 3v square, let us substitute here, minus 15 v square it becomes. Okay, so if you solve this you will get u1 equal to 4v. This is the answer. Once go through the concept, and similar problems also you do. It is in our test series. Another important problem: an insect of negligible mass is sitting on a block of mass capital M tied with a spring of a force constant K. The block performs simple harmonic motion vertically with amplitude A in front of a mirror which is inclined at 60 degrees with the vertical. So it is given in figure. The maximum speed. So this is maximum speed of insect relative to its image is. And see the diagram. A spring and the mass attached is capital M, and this is the insect. Okay. So what is happening? It is oscillating. The spring is under a simple harmonic motion. It is oscillating, and in front of it here a mirror is placed that makes 60 degrees with the vertical. Then what is the relative to its, what is the maximum speed of insect relative to its image of insect? So this is very interesting. We'll see. Before that, a small concept we'll see. Here it is combination of two cases. One is simple harmonic case. So in simple harmonic motion, the velocity of particle is, which is executing simple harmonic motion, omega into amplitude a square minus displacement of it, y square. Maximum means at mean position velocity of the particle is maximum. So y equal to 0, the maximum velocity is omega a. This is the maximum velocity. Another concept here, mirror. So in case of mirror, for example, you take a mirror. If object is moving with velocity v and its image also moves with same speed in opposite direction. So here relative velocity of object with respect to image you can write as VO minus VI. So obviously image velocity is opposite to that, so minus of minus plus VI you can write. And if object is moving say along the mirror in vertical direction or downward direction, whatever, okay, in vertical or downward direction, so there is no change in velocity, speed will be same. That you remember. This is the basic concept here. Now we'll solve the problem. Here you can pause the video, try to solve the problem. This mirror, we'll draw mirror, it makes 60 degrees. And what is the velocity? Velocity of the insect is, the maximum velocity direction is downward. Let us resolve into components. Okay, one component will take parallel to the mirror, another component is perpendicular to the mirror. Okay, this angle becomes 60 degrees. This is the velocity of insect. If you resolve into components, along the mirror it is V cos 60 degrees, and perpendicular to that V sin 60 degrees. Let us draw its image. Velocity, this velocity V sin 60, and the parallel component, this is V cos 60. So okay, the velocity of insect with respect to its image, and we can write as simply 2V, as I said in basic concept, V 2V sin 60 degrees. This is omega A sin 60 is root 3 by 2. So this is omega root 3. Here omega means in simple harmonic motion in terms of spring constant, the angular frequency or angular velocity is equal to root over k by m. This you remember, and if you substitute here, see 2 can cancel. This is root 3 a omega is root k by m, or you can write a into root over 3 k by m. This should be the answer. Okay, so what are the options? We'll check. Root 3, so option 1. If you take 4 outside, 2 get cancelled, this is the option. Okay, once go through the concept and also try to solve the similar problems.